So hello students, myself Trishti Sharma, and today I am going to start with your chapter alcohol, phenols and ethers from your class 12 chemistry. And today's video is basically on the topic preparation of phenols. Today I am going to deal with preparation of phenols in this video. So let's get started. And what is phenol? Phenol is also known as carbolic acid. First of all, you should know this name. This name is very important because sometimes in competitive exams or sometimes in your CBSE boards as well, they give the name carbolic acid and students mostly get confused over here. So you should know it that it is the name for phenol. So let's get started then. First preparation is from benzene sulfonic acid. Now benzene sulfonic acid, as the name suggests, is what? We have a benzene ring and we have a SO3H group over here. And you know how benzene sulfonic acid is prepared. Benzene sulfonic acid is prepared from the sulfonation of benzene. So we have benzene ring and it will undergo sulfonation in the presence of concentrated H2SO4 in the presence of nitric acid, or you can say you can also take oleum over here for sulfonation. Okay, so after sulfonation you will get SO3H group added over here and you will get what? Benzene sulfonic acid. Now how to prepare phenol from this benzene sulfonic acid? When this benzene sulfonic acid, it is treated with molten alkali, NaOH. When it is treated with molten sodium hydroxide, it will give what? Sodium phenoxide. So what is sodium phenoxide? Phenoxide ion is what? Phenoxide ion is benzene and O negative. As we know, phenol is what? Phenol is this. This is phenol. So this is the ion of phenol that is known as phenoxide ion. So it will give what? Sodium phenoxide. What do we mean by sodium phenoxide? O negative charge is there and sodium positive will what? Neutralize this charge. So this is what? Sodium we have got from NaOH and it will neutralize the charge of oxygen over here, and this is what? Sodium phenoxide. Sodium phenoxide. Now this is a salt. This is basically a salt, and how you will get phenol from it? When this sodium phenoxide is treated with water, reacted with water, undergo hydrolysis. When it undergo hydrolysis in the presence of acid, it will give you what? Phenol. Phenol. So we will get phenol over here. We will get what? Phenol over here, and along with it we will get NaOH. Why NaOH? Because Na positive, you are doing hydrolysis. So water will get split into H positive and OH negative. Now this O negative will go with this H positive will go with O negative and OH will go with Na positive, and you will get what? Phenol. I think it is clear to you now. So let's then move ahead. If this preparation is clear to you, let's then move ahead with your second preparation, that is Dow's process from haloarenes. From haloarenes. Now I am going to start with the second preparation of phenol, that is from haloarene, and this is also one of the important preparation of your phenol from haloarenes, that is Dow's process. Dow's process. So basically we use chlorobenzene over here. So chlorobenzene, we are using chlorobenzene over here. When this chlorobenzene, it will undergo fusion with sodium hydroxide, and what will it give? It will give us sodium phenoxide. On treatment with NaOH under certain temperature and pressure conditions, temperature is what? 623 Kelvin, 623 Kelvin, and 320 atm is the pressure. So under this pressure and temperature condition, when chlorobenzene it undergo fusion with your NaOH, what will you get? You will get what? Sodium phenoxide. Sodium phenoxide. And sodium phenoxide, as you know, on further acidification, this sodium phenoxide will yield what? Phenol. On further acidification means you can use acid over here. As I am using HCl over here, so what will happen? I will get phenol. I will get what? Phenol. Plus I will get NaCl. Phenol plus NaCl. H positive will go to O negative and it will form phenol, and Na positive will bind with the Cl negative of HCl and it will give what? NaCl. And NaCl is removed over here and you will get phenol as your main product. So now let's move on to the next preparation. Now next preparation is what? From diazonium salt, and this is also a important preparation for phenol from diazonium salt. So what is the diazonium salt? Diazonium salt is what? N triple bond N positive, Cl negative. N triple bond N positive and Cl negative. So this is what your diazonium salt. This is BDC, benzene diazonium chloride. Now, how have you prepared this diazonium salt? From in preparation of this diazonium salt, what you do? Diazonium salt is prepared from your aniline. You have aniline over here. You have aniline over here. This is what aniline. Then you react it with NaNO2 in the presence of HCl, or you can simply say HNO2. You will get what? Benzene diazonium chloride. Now mechanism of this is not specified here. So you will get what? Benzene diazonium chloride with NaNO2 in the presence of HCl from what? Aniline. So this is what? BDC. Now how can you prepare phenol from this benzene diazonium chloride? In order to prepare phenol from this benzene diazonium chloride, it is very easy. You have to just do hydrolysis. Just hydrolysis, you will get what? Phenol. On hydrolysis, you will get what? Phenol over here, and N2 gas will get released, N2, and what you will again get? N2 plus HCl. So nitrogen will escape like a gas and you will get phenol plus HCl. So this is from benzene diazonium chloride. Why benzene diazonium chloride is so reactive? It is reactive because it has this N triple bond N over here. You can easily form many species from this benzene diazonium chloride. Like I have specified here, phenol. You can also prepare many other aromatic compounds from this benzene diazonium chloride. Basically, why so? Because it has N triple bond N over here, and this N triple bond N, it can easily escape as nitrogen when it is reacted, and you will get what? Product. So this is the second preparation. Now let us start with the last preparation of phenol, which is the most important preparation and most useful and most, you can say, economical preparation for phenol. Second is from cumene. So cumene is what? Cumene is isopropyl benzene. Cumene is what? Isopropyl benzene. And this method is the best method for worldwide production of phenol, and it is from what? Cumene. Because this method is economical, the raw materials are not wasted over here. This process is industrially very important process to prepare phenol. So isopropyl benzene. First of all, let me specify you what is isopropyl group. Isopropyl means CH. Propyl means 3 carbons. So this is what my isopropyl group is. This is what isopropyl group. And I am saying that cumene is what? Isopropyl benzene. So what is cumene then? Cumene is isopropyl benzene. So this is my cumene. This is what? Cumene. Now this cumene on reaction with oxygen, or you can say on oxidation, what will happen? On oxidation, what will happen? You will get what? Cumene hydroperoxide. You know what is peroxide linkage? Peroxide linkage is this one. This is peroxide linkage and this is a weak linkage and it can easily break down to give your products. So on oxidation, cumene gives cumene hydroperoxide. And what is cumene hydroperoxide? It is here your oxygen will get added in between these two bonds, CH and CH3 bonds, and you will get what? COOCH3. Oxygen. You will get what? CH3 over here. So what you will get? Oxygen will get added over here. So this is your cumene, and oxygen will be added in this between this CH bond, and you will get what? Hydroperoxide here. So this is cumene hydroperoxide. Now, as I already said you that this hydroperoxide or peroxide linkage is weak and it can be easily cleaved. So what will happen? I will further do its hydrolysis in the presence of acid. Hydrolysis in the presence of acid will give me what? It will give me phenol as the product. So this is phenol, plus I will get acetone, CH3CO, CH3, acetone, and phenol. I will get it as a product. So this is my preparation of phenol from cumene, and this is very important preparation. This is very important preparation for phenol. And most economical method to prepare phenol is from cumene, from oxidation of cumene. Basically it is undergoing oxidation over here. And oxidation, and in second step further hydrolysis in the presence of acid will give you what? Phenol. So this was for the preparation of phenols. That's all for today's lecture. So thank you everyone.